In this module, we will cover the chain of responsibility pattern. Its intent is to avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. I am Kevin and I'll guide you through it. We'll start by describing the pattern. As a real-life example, we will use a document validation and approval chain. After that, we will map that to a structural example and implement the real-life example in a demo. As you're used to by now, we will continue with learning about use cases for this pattern, pattern consequences, both positive and negative, and related patterns. Let's continue with describing the chain of responsibility. The chain of responsibility pattern is a behavioral pattern from the Gang of 4 library of design patterns. Its intent is to avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. It does that by chaining the receiving objects and passing the request along the chain until an object handles it. Let's clarify that with an example. We're building part of an application which validates a document. The first thing that needs to happen is ensure that a document's title is filled out. Up next, we've got a requirement that the document's last modified date must be less than 30 days old. If those check out, the document must be read and approved by the litigation department, after which it can be sent to the manager and approved there. Only after the manager has approved the document, it's considered valid and can be sent to the customer. As you gather from our code example, that's a lot of conditional statements that need to evaluate to true before the document is considered approved and ready to send to a customer. The method that checks the document becomes bloated and hard to manage, and there is no easy way to reuse these checks in other parts of our code. Enter the chain of responsibility pattern. The idea is that we're going to put all these validations and approvals in objects of their own, handlers. So we end up with an interface, say iHandler, which states that there should be a method to handle the incoming request. We could scope this to a document class, as that's what we're using in the example, but using generics makes this more reusable, so that's what I'd suggest. As each handler can pass the request on to the next one, we also need to provide a way to set the next handler. That's the potential successor. For each of our validations, we have an implementation of this interface, a handler. So we've got a document title handler, a document last modified handler, a document approved by litigation handler, and a document approved by management handler. For readability purposes, I only put 2 on screen. What these handlers do is get the document passed into their handle method and can then execute their part of the document validation. If the validation doesn't check out, we don't continue. But if it does, we can continue to the successor. Like that, the document flows through the chain. And of course, we have a client that initiates the request. The client chains the handlers and provides it with a document to validate. Before we continue with mapping this to the pattern structure, there is something I'd like to point out. The example I've used is a real-life example that's in line with today's interpretation of the chain of responsibility pattern. However, were you to look up the original implementation from the Gang of 4 book, you'd notice it's a bit more strict. In that interpretation, a request moves up a chain of handlers, and each handler simply checks whether it can handle that request or not. If it can't, nothing happens to the request except passing it on. And if it can handle it, it's handled and not passed on anymore. Both are, in my opinion, valid implementations. By the way, as a side note, for those of you who've worked with ASP.NET Core, this should feel quite familiar. You're looking at a slide from my Web API Fundamentals course in which I describe how the ASP.NET Core request pipeline works. Essentially, you're chaining pieces of middleware that can handle and or alter a request and potentially pass it on to another piece of middleware. That is a prime example of the chain of responsibility pattern at work. Let's map our example to the pattern structure. The first player in our pattern structure is the handler, which maps to our iHandler interface. This defines an interface for handling requests and optionally implements the successor link. Then we've got our concrete implementations, which are named concrete handler. These handle requests. They can access the successor and potentially pass on the request to it. Lastly, we've got the client. The client is responsible for initiating the request to a concrete handler object on the chain. Time for a demo. In this demo, we will implement the chain of responsibility pattern using our document validation example. So let's start with the document class so we have something to validate. This is a pretty straightforward class. A document consists of a title, a last modified date, and two booleans stating whether or not it's been approved by litigation and/or management. In the constructor, we accept these four values and set the properties. Then we need to create an interface for our handler. This is the handler component from the pattern structure. You could potentially use an abstract class for this as well if you want to provide some basic implementation logic. We're okay with an interface, and we name that iHandler. We also make it generic so we can use it on other classes as well and not just on the document class. It has a method, handle, which will handle the incoming request. The request that comes in is of type T. That's our document. We also need a way to set the successor, the next handler in the chain. For that, we define a setSuccessor method which accepts that next handler. We conveniently have this method return an iHandler of T, that's the successor. This creates a fluent interface, allowing us to easily chain these handlers. Then let's implement a concrete handler for checking the title. We'll name it Document Title Handler, and we'll have it implement our iHandler interface. The type we pass through is document, because that's what this handler works on. Let's implement the interface. In the handle methods, we do our validation. Let's rename the parameter that comes in. We check whether the title is empty or not. If it is, validation fails and we throw a new validation exception. That's defined in system.componentModel.data annotations. It's built in the framework, so let's import that namespace. And there we go. If the title isn't empty, we can go to the next handler. But we haven't got a field for that yet. So let's add a new field, successor, which we will use to store a reference to the next handler in line. Now we can call handle on the successor, passing through the document. Note that successor is nullable. A handler doesn't have to have one. We only go to the next handler when successor is not null. Then we need to implement the setSuccessor method. This is pretty straightforward. We simply set the successor field, and we return the successor itself, which, as mentioned, will allow us to fluently chain another one. That's it for our handler. We have 3 more to go. The only thing they're different in is the actual validation rule. The first one is the document last modified handler. We check whether the document was modified in the last 30 days. If it wasn't, we throw a validation exception. Otherwise, we potentially continue to the next handler in line. The setSuccessor method simply sets the successor value, as was the case with the previous handler. Our next concrete handler is the document approved by litigation handler. It follows likewise principles as the previous 2 handlers. The only difference is in the handle method, where we now check whether approved by litigation is true or false. And then we had our last handler, the document approved by management handler. Again, following the same principles as our other handlers. The only difference is that here we check the approved by management boolean. That's it for our implementation. Let's write a bit of code to test this. Let's create a valid document first. We need to import the chain of responsibility namespace for that, so let's do that. We pass through a title, a last modified date, and values stating that this document was approved by litigation and management. And now we create a second one, invalid document. As the name implies, this is invalid, and we can see that because the boolean we passed through as value for the approved by litigation field is false. Now let's create our chain of handlers. We start with a document title handler. That was our first validation rule. And then we chain the other three handlers. For that we can call into setSuccessor, passing through instances of the handlers we want to add as successor. Seeing setSuccessor returns an I handler, we can chain these three statements. And with that we've got our chain. Now let's effectively call handle on the chain. I'm surrounding this with a try-catch statement in which I catch a validation exception, which is defined in system.componentModel.data annotations. And I do that because, well, if all works out, we should hit a validation exception when handling the invalid document. So the first thing we do is try and handle the valid document, which should work out, and then we try and handle the invalid document, which shouldn't work out, and throw an exception, which we catch and then write out the message to the console output window. Let's add a read key statement, and let's give this a try. And there we go, our valid document is valid. We never see invalid document is valid written out to the console output window, but we do see a validation exception message. The document must be approved by litigation, which means it isn't valid. Let's have a look at the use cases for this pattern.